enough of the product rule to kind of help us with this then. So this is what I passed out today. So what I'm going to look at is something that we've learned how to do, and I'm going to use this example to kind of teach this basically. So if you were going to do this problem right here, I'm going to show you two ways to get the derivative on this. And the idea on this is you have two ways. You could go through and you could do the derivative of each part. Okay, it's kind of tedious to write this out, but I'm trying to make a point on this. So we're going to do the derivative of each part and then add it together. Okay, that's one of the properties of derivatives we've learned how to do. Okay, now I realize you can do this problem in your head, okay, but I want to emphasize again something that will lead us to the product rule. Okay, so what is the derivative of 3x? 3. What's the derivative of 4x? 4. And the derivative of 5x is 5. So if you added those numbers together, you would get 12. Okay? You could also do this problem this way, and I think it would probably be more sensible if you just did it this way. Hey, these are all like terms. So you have 3 plus 4 plus 5 is going to be 12x. And then, of course, the derivative of 12x is 12. So what I'm trying to show you on this is if you take the derivative of the sum, it's the sum of the derivatives. We learned that format, and then the idea is going to be if we had a product, would it work the same way? So what I want to look at on this before we go to the product rule is I want to do this and just see if this happens. So what we're going to do is we're going to do, first of all, kind of like we did here, collect the like terms. Okay, if you collect the like terms here and got 12x, the derivative was 12. So if you multiply those two things out, what do you get? X to the 6th, okay, because you add exponents, okay? Now, what is the derivative of x to the 6th? 6x to the 5th, okay, yeah, good, 6x to the 5th, like that. Okay, now my question is going to be, does this work? So let me show you what I'm talking about. Okay, just like on the first problem, we were able to do the derivative of each part and add them together. What I'm curious about would be if we did the derivative of x squared, did the derivative of x to the 4th, then multiplied, would we get the same answer? Okay, and this is a real important thing to pay attention to see if this works or not. So this is, what's the derivative of x to the 2nd? 2x. What's the derivative of the next one? 4x cubed. And then if you multiply that out, you get 8x to the 4th. Okay, compare. Look at that. It doesn't work. Okay, it never does. Okay, it's a nice thing to try, but it doesn't work. So if you have sums, it's okay if you have sums to just do the derivative of each part. That's fine. But if you have a product, you can't do the derivative of each and multiply. It does not work. Okay? So what we have is we have for this, we have what's called the product rule that I'm going to introduce you to today and show you kind of how this works. Okay? This is going to be a fundamental rule that you're going to use so often that you're going to have to memorize this. Okay? So what this idea is if you have two functions multiplied, this is what you do. You write down the first function and you don't touch it. Then you do the derivative of the second. Then you add, then you do it backwards. You write down the second function and don't touch it. Then you multiply by the derivative of the second. One thing that's always real helpful on this formula is to learn it in words. Don't learn it in symbols, learn it in words. So if you think of f of x as the first function, think of g of x as the second. The way it goes is you do the first times the derivative of the second plus the second times the derivative of the first. And you can even write it down this way if you want to. So like you have f times s, that stands for the first times the second. Then it's just first times derivative of second plus second times derivative of first, like that. Okay, that's what works. There's a proof of that. I'm not going to go over the proof, but I did put it in the notes that you can look over if you're interested, okay, which I'd like people to look through that. So what I'm going to do now is I'm going to show you on the example I just did how you would do the product rule and how it works. Okay, so let's go down here and let's look at this example down here at the bottom now. Okay, so now we're ready to do this by the product rule. Okay, so if you were doing this problem by the product rule, here's how you do this. Now you're going to see me using what I call Leibniz notation a lot more now. So what you do is the first is x to the second. So what do? You write it down. You don't touch it. Then you multiply by the derivative of the second, which is the x to the fourth. Then you add to that, well, you do it backwards. You write down the second, which is x to the fourth, and then you multiply that by the derivative of the second, like that. So again, what did I do? I did first times derivative of second plus second times derivative of first. Okay, like this. All right, so what do we have? We have x squared here. What's the derivative of x to the fourth? 4x to the third. Then we have x to the fourth. And what's the derivative of x to the second? 2x. Okay? Now when you put this together, that is really going to be 1 times 4, or 4x to the fifth. Okay, like that. Okay? And then this is going to be plus 2x to the fifth. Those are like terms, so you get 6x to the fifth. Like that. Now, what I want you to notice on this is what I was trying to do at the top of the handout is obviously the easiest way to do this problem would be to do this. Put the like terms together, right? Okay, now what's the derivative of x to the sixth? Okay, so I'm just trying to show you that that's a demonstration. It's not a proof that the product rule works. It's a demonstration that it works. Okay, so that's the idea. That's one of the simplest ways to introduce somebody to that idea is to show a simple example like that. Okay, so let's go to the next page. And what we're going to do is we're going to learn how to do the product rule. Now, this is Leibniz is one of the inventors. Look at that. He even has his face on a stamp. Mathematicians can have their names on a stamp. Okay, he didn't invent, he discovered the product rule in 1675. This is the proof. I'm not going to go over the proof, but it's a decent thing to go through, particularly if any of you are interested in higher math and more the theoretical part about this. You want to take some time going through these proofs that are a little bit more complex. So what I'm going to do is let's go to this example 1, and we should have time to go through and crunch out a few of these examples. Now, I'm not going to do this on all the problems, but if I ask you to differentiate this, you have two choices. Let's first of all just multiply it out, and then let's do the product rule. So let's go ahead, and I'm going to be real careful when I multiply this thing out this time, okay? So that is going to be 3x to the third, and then plus 9x to the second, plus 3x, okay, then minus 4x to the second, and then minus 12x, and then minus 4 like that. Now we're going to collect the like terms, then we're going to do the derivative in that order. Okay, so let's see, we get 3x to the third here. Like terms are going to give plus 5x to the second, minus 9x, minus 4, like that. Okay, now just do the derivative in your head. Now the way you notate this most of the time, when I do this Leibniz notation, if I say d dx, I'm just asking you to find the derivative. Generally, if you're using Leibniz notation, you write the answer like this. You say, okay, it's the derivative of y with respect to x. So in your head, what's the derivative? 9x squared plus 10x minus 9, okay, by using the power rule. Okay, so that should be the derivative. Okay, now that's the standard way that I taught you how to do this in the last section today. Now you can do the product rule if you want to, and that bypasses having to multiply this out. So let's do the product rule, which goes like this. Okay, you do the first times the derivative of the second plus the second times the derivative of the first. Okay, so when we do this derivative, dy over dx, we're going to get this. What you do is write down the first. The first is the first function that's being multiplied. So you just write it down as 3x minus 4. Now, I like to get students to at least write this step. Now you're going to do the derivative of the second. I understand you can do that in your head, but learn to write it down. Start developing the habit of writing that down like this, because you want to know how to use this notation correct. Then you write down the second. You don't touch it. You just write down the second, which is x squared plus 3x plus 1. Then you're going to multiply that by the derivative of the first. Okay, like that. So learn to write it down that way. Okay, one of the things that students sometimes struggle with in this class, they don't write things down right. You got to learn how to write the notational system down correctly, and you're probably a little bit less likely to make mistakes if you get everything cleanly written out like that. Okay, so I did first, derivative of second, plus second times derivative of first. Now, a lot of this problem you'll be able to do in your head. So this is going to be 3x minus 4. Okay, what is the derivative of this thing right here going to be?
2x plus 3.
2x plus 3, good. Do that in your head. Okay, now go to the next one. Just write down the x squared plus 3x plus 1. Don't touch it. Okay, and then what's the derivative of 3x minus 4?
3.
That's 3, so I'll just put a times 3 like that. Okay, now we're going to multiply it out, okay, and we'll see if we get the same answer. Okay, all right, so we got a FOIL. So if we FOIL this, we're going to get 6x the second. You can go ahead and start, the FOIL on this. And then plus 9x, minus 8x, and minus 12. Okay, then we're going to multiply everything by 3. We got to do a distributive property here. So that's plus 3x squared, plus 9x, and plus 3. Okay, let's see what kind of like terms we have. It looks like we have 6 plus 3 is going to be 9x the second. Okay, it looks like we have 9 minus 8 is 1. 1 plus 9 is 10, so that's matching up. And we got negative 12 plus 3 is going to be minus 9. Look at that, we got the same answer. In this case, which one was easier? The first way. Sometimes it is. A lot of times the product rule simplifies it, but sometimes it doesn't. So generally, a problem like that at this level is sometimes, to me, it's just best to multiply it out and then do the derivative. Okay, do whatever's simpler. Okay, but either way is going to work out. Okay, do you guys understand how that product rule is working then? Okay, first, second, second, first. Okay, you want to do it in that, be sure that you do it in that order carefully then. Okay, well, let's run through a few more of these to finish this up here. This one I think we'll do example 2. I want to do one more kind of both ways. So let's start by just multiplying this one out. So we have, and what you need to do on this, since we're going to do a derivative, what do you need to do with that square root of x? You need to write it as x to the 1/2 because you know you're going to do a derivative. So you need to do that. And then we're going to multiply that by x squared. Okay, now there is some algebra issues in here a lot of times that students need a little help with. So this is really a distributive property. So we're going to take 4x to the 1/2, and we're going to multiply that by x to the second. Then we're going to take these and multiply them, so we're going to get 3x to the second. Okay, the algebra issue on this is what do you do with these exponents on this part of the problem right here? You add them, right? Okay, it's no different than having x to the third times x to the fourth is x to the 7th. You got to add those exponents. So you're doing 4x to the 1/2 plus 2. Now I'm going to write that 2 as 4/2 so that I have a common denominator. Okay, because you're going to do that all the time in this class. Okay, so then when you multiply that out, you're going to add the exponents. You have 4x to the 5/2 minus 3x to the second like that. Okay, so you got to do that a lot of times. You got to add exponents that are fractions, so you got to work with common denominators and stuff. Okay, now we're going to do the derivative, dy dx, because that's what the problem, what we're trying to do is do that derivative. So when we do this, you're going to write down the 4, you're going to bring down the 5/2. Okay, then you're going to subtract 1 from the exponent. So when I subtract 1, I'm going to do 2 over 2, like that. And then the derivative of 3x to the second, what is that? That's 6x. You can do that one in your head. Okay, so now if you put the 4 over 1, the 4 over 2 reduces to 2. So that looks like that's going to be 10x to the 3/2 minus 6x. Now I'm going to just leave it there. Now we could change that to a radical, but I'm just going to leave it there and you can do that unless you're directed to go further. So that would be what that derivative is, if you multiply that out. So what I want to finish up with here is let's just go ahead and do the product rule together on this and see if we get the same answer. So first thing I want to do before I do the product rule, let's write this as 4x to the 1/2 minus 3 times x squared. Okay? And again, what we're doing is first times derivative of second plus second times derivative of first in that order. Okay, so let's put this together and see if it's any easier this way. This may be just about as hard. I don't know. Okay, so you write down the first. The first is this first function that's in parentheses, so just write it down. Okay, so that's going to be 4x to the 1/2 minus 3. Then you're going to multiply that by the derivative of the second, which is just the x to the second like that. You have two functions being multiplied, so you have that. Now you're going to write down the second, which is x to the second. Then you're going to multiply that by the derivative of the first. Okay, now we're ready to do the derivatives, and then we'll generally have some algebraic simplification. So the calculus part is almost done. You have to put that in the quotient rule, and then what you need to go ahead and work on is you want to go ahead and work on those two derivatives now. So you're going to end up having 4x to the 1/2 minus 3, and then this derivative is what? 2x, okay? And then this one, when you do this derivative, you got to maintain those parentheses. You're going to have, and see when you do this, you're really doing 4 over 1 times 1/2, x to the 1/2 minus 1, like that. That's kind of what you do. You after practice a little bit, you start learning how to do this in your head. But 4 over 2 is 2, so that's going to be 2 there. That's going to be x to the negative 1/2, like that. And then the derivative of 3 is what? 0, so you don't do anything with that. So that's an unsimplified derivative right there. We just need to simplify it and see if it takes us back to what we did the other way then, okay? So what we'll end up having on this is you got to do a distributive property now, so you got to take this times this, so you got to take 4x to the 1/2 times 2x. Then you got to take 2 times negative 3 to get negative 6x, like that. And then this, you're just going to multiply and add the exponents. So I got x squared times 2 times x to the negative 1/2. Okay? So I find that most of the time students do okay with the calculus on a problem like this, but where they fall apart is with the algebra. So what we're going to do is we're basically on this one got to add these exponents. So that's a 1/2. That I'm going to write as 2/2. That way I have a common denominator, see. So this is going to be 4 times 2 is going to be 8. And then this is x to the 3/2. When you add those things together, then we have the minus 6x. Okay? And then when you do this, okay, what you're really doing on this, you're doing this arithmetic. You're doing 2 over 1 minus 1/2. So you can change the 2 to 4 over 2 minus 1/2. So notice you get 3/2 again. So this whole thing is going to give 2x to the 3/2. Are you going to get the same answer? Mm-hmm. Yeah, okay. Again, which way do you think's better? I think the first way is easier. What do you think? Yeah. It's not always that way, but one of the reasons I want to go through this is I want to teach you to do it the easy way. Okay, there's going to be situations where the product rule is easier, but if it isn't, don't waste your time with it, because you'll probably do better. That's important, okay? But the product rule you have to learn about, because there's times when you have no choice but to do that then. All right, so that will wrap us up on this. We'll work a little bit more on this